Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Okay, so today we will continue what we've learned so far about structural analysis. So if you missed the previous lecture, so please check the link in the description down below. Okay, so in the previous lecture we've talked about the force in a member can be a tension and can be a compression. Okay, so now we are going to look at a method, okay, that can help you to calculate or determine the force inside those members. Okay, so the first method here is method of joints. So let's refer back to the previous figure, okay, which is this truss here. So as you can see here, for this truss here, we have at point A here, okay, we have something that is fixed on the ground here, and then at point or at joint C here we have a roller, okay, this one, and then at joint B here we have an external force which is 500 Newton. Okay, now I'm going to show you on how we can calculate the force inside the member A, B, B, C and also AC. So first, what you need to do first is that we need to draw the free body diagram of this truss. Okay, so we have a truss, okay, like this, okay, and then we have 500 Newton, okay, pointing in this direction at B here, and then at A here, okay, we have this one. Okay, so refer back to our previous topic about the reaction force. Okay, so here at joint A here, this joint here fixed to the ground here, so means that we cannot move it in the X direction or in the Y direction. So means that if we cannot move, we have a reaction force. Okay, so we do have a reaction force at A, which is Y direction, okay, AY, and also X direction, which is AX, okay, because we cannot move it into Y, so we have AY. We cannot move it into X direction, so we have AX. Okay, so let's look at joint C here. Okay, at joint C here, this is a roller, so this roller can move freely in this one, in X direction. So because it can move freely, so we don't have any reaction force at C, but we cannot push, okay, this one downwards. We cannot, okay, we cannot move it downwards, so means that we do have an upwards reaction force. Okay, so we label it as CY. Okay, Y represents Y direction lah. Okay, so here C, okay, C. So here we have three unknowns, AX, AY and also CY. Okay, so before we can start to calculate method of joint here, okay, it is best for us to find this reaction force first, okay, the value. Okay, how to do it? So now we have the distance is 2 meter and the angle is 45 degrees Celsius. Okay, because it is in equilibrium, means that total of force is equals to 0, total of moment also equals to 0, so we can use that one to create or to calculate this AX, AY and also CY. Okay, so if you look carefully here, AX here is the only unknown force pointing towards X direction. Okay, correct? Okay, so means that we can start from total of Fx equals to 0. Okay, AX is equals to 500 negative 500 Newton. Okay, if you get the answer negative, don't be afraid, because this negative here represents the actual direction of the force is actually opposite direction. Okay, so we just make an assumption. Okay, at first we make assumption the force here is pointing to the right. But when we calculate, the answer is negative. So means that the actual direction of this AX here is to the left. Okay, to the left, not to the right, but to the left. Okay, don't change, no need for you to change the free body diagram here. No need, just maintain. Okay, AX here is negative 500 Newton. Okay, maintain. Okay, AY and CY, we cannot use total of FY equals to 0 because we will have two unknowns in one equation only. So we can use what? Yeah, we can use moment. Okay, so if we use moment at joint A here, this one, at joint A here, no need for us to include AX and also AY in our calculation. Okay, the only unknown is CY only. Okay, so CY here is equals to 500 Newton. Okay, so we know CY, we know AX. Now the only unknown is AY. Okay, to make it easy, we just use total of FY equals to 0 to calculate AY. AY is equals to negative CY, which is negative 500 Newton. Okay, finish. Okay, so here we know AX is negative 500, CY is 500, and AY is negative 500 Newton. Okay, so next, now is the time that I will show you how we can use method of join. So to use method of join here, what we need to do is that we need to focus on a joint only. Okay, so if you can see here, this one, so let's look at joint A, this one. Okay, let's look at joint A. So at joint A here, this one here, okay, if we focus on joint A here, so we can see that we have a member like this, a member like this, and also at A also we have a reaction force which is AY and also AX. Okay, do not look at other part here. Do not look at B, do not look at C. Only at A only. This one only. So in for the method of join here, okay, at joint A here, okay, we will have, okay, reaction force, we have AY, and also we have AX. Okay, then as I mentioned earlier, we have a member here. Okay, so what you need to do is that you just change the member into a force. Okay, because we want to determine the force inside the member, so we just change the member into a force. Okay, so we have two kinds of force inside the member: compression or condition, compression or tension. So if it is a tension, means that the force is pointing outwards from the joint. If it is a compression, the force is pointing inwards. Okay, means that to the point. To make things easier, okay, please assume everything to be in tension first. Assume everything to be in tension. Okay, if we assume everything is in a tension, so we will have this one, okay, force A to B, okay, and we have force A to C. Assume everything to be tension, so means that we assume everything is pointing outwards of the joint here. Okay, so now we have a free body diagram at joint A. We know the value of AX already. We know the value of AY. So here we can find the value of FAB and the value of FAC. Okay, we can use what? So in the method of join, we can only use total of force equals to 0. We cannot use moment because we don't have any distance, okay, to use moment. So we use total of force equals to 0. So let's do Fx equals to 0. So FAC is equals to negative AX, Okay, so what is the value of AX? So if we refer back, AX here is negative 500 Newton. Okay, so if we get the value is negative 500 Newton, make sure you insert the negative value also. So means that FAC is equals to negative AX, so negative 500 Newton. Therefore, okay, write it down downward okay. So therefore, FAC is equals to 500 Newton. Okay. So here, the value here is positive 500 Newton. As I mentioned in the condition of AY here and also AX, when we get the value of negative means that our direction is actually opposite direction. So if the value is positive means that our assumption about it to become tension is correct. Okay, so means that this is the direction of force AB. So means that it is a tension. Okay, so we label it as a tension. This one T. Easy, Okay, very easy. Okay, so what about FAC? So FAC here we can use total of force in Y. Total of FAC done. FAB So FAB here we can use total of force in Y direction. So FAB is equals to negative AY. Okay. AY is what? AY is negative 500 Newton. So as mentioned earlier, so please make sure we use negative 500 when we want to insert the value. Okay, maintain the negative. So here, therefore, this one FAB is equals to 500 Newton. So because the answer is positive, means that our assumption of it to be a tension is correct. So this one is also a tension. Okay. So to make it easy, if the answer is positive, so it is tension. If the answer is negative, it is a compression. Okay. Let's see whether we have a compression situation or not. Okay. Let's do, the second one. Let's try to do at joint C here. Okay. Let's try to do method of joint at joint C. Okay. So at joint C here, we have a force like this. Okay. In this member and also in this member. Okay. So these two forces of the member here. And also we have an reaction force. We have a reaction force at CY here. Okay, so when we do at joint C, okay, so this is the free body diagram at joint C here. Okay, we again focus on joint C only. Do not look A and do not look B. Okay, so here we have CY. Okay, we already know the value of CY, which is 500 Newton. And we have FCB in 45-degree angle and also FCA pointing in negative X direction. Okay, to make our calculation easier, okay, if you can see here, FCB is the only force that we can resolve it to Y direction. Okay, FCB we can resolve it to Y and also to X. And CY is pointing towards Y also. So let's start with total of Fy equals to 0. So we have okay, so now we've done calculating FCB here. So if you can see here, when we insert the value of CY, which is 500, we get FCB is negative 707.11 Newton. So we get the value is negative. So our assumption is tension. So because it is negative, means that the correct direction is opposite direction. Therefore, FCB is compression. Okay, negative compression, positive tension. That's it. Okay, so let's try to calculate FCA. Okay, so we've done calculating the value of FCA when we do total of force x direction equals to 0. So as you can see here, we got FCA is equals to 500 Newton tension. So let's compare with our previous answer. FAC is equals to 500 Newton tension. Same answer, huh? Okay. So as mentioned in the previous video, okay, FAC and FCA will have the same magnitude, okay, and also the same type of condition, which is tension. Okay, so we get the answer same with at joint A here. So if you get the same answer, the same tension or compression, means that your calculation is 99.999% correct. Okay, so actually we already finished calculating FAC, member FAC, member FAB, and also member FCB. Okay, we have AB done, AC done, also BC also done. Okay, so for your own exercise, okay, use this method of join, okay, to calculate this one. Okay, to calculate the member at joint B here. Okay, do this by yourself first. Okay, try to do this one. Use method of join to calculate the member at joint B here. Therefore, we will have B to A, this one, and also B to C. Okay, you are supposed to get the same answer. Okay, so please try to do this one on your own. If you have any question, feel free to ask me, and see you again in the next video. Bye bye.